All right, guys, we got the lab fixed. We're good to go. Something weird is going on with port 3 on the Fortigate. So switching to port 4, did it, weirdly enough, did some reboots. So I'm going to give Don credit. I think Don fixed it, you know. But here we are. So I did, of course, you see the lab. We have the scenario is the reason for this lab is that we're going over IPSec. I want to emulate that, show you guys how that's configured, the who, where, what, and why, right? And how it looks in a virtual environment, right? Using like an evaluation license version of Fortigate, okay? So let's hop on in. So the goal here is, right, we have two private networks. We have 172.16.11.0/24 behind site 3, okay? So that's one private network. Then the other private network behind site 4 is we have 192.168.11.0/24. Okay, and so our Fortigate is our layer 3 boundary for our local area network. Okay, so it's gonna go through, of course, the Fortigate, go through firewall policies, get checked with our UTMs, right, our Unified Threat Management. Once it gets checked, it's going to be passed on to the internet, right? And so the goal here is that we want to go ahead and be able to communicate, from Site 3's local area network to Site 4's local area network without having to use network address translation, and also without having to add manual routes to Site 3 and Site 4 for each other's private network. Okay, how can we do that? We can do it with IPSec. Okay, so what I'm going to do is I'm going to log into the GUI, and we're going to walk through configuring IPSec using the IPSec wizard. Okay, so let's go ahead and do that. All right, hopefully you guys can see my screen. Okay, so what we're going to do if we want to go ahead and configure IPSec, right? One major thing we need to make sure we have set is we have layer 3 configured, right? We want to make sure that we have our static routes configured, right? If we're connected to the world, we need internet. We need internet connection, right? A viable internet connection to our ISP. Why is that? Because the whole purpose of IPSec is securing our traffic going over an untrusted network, which of course, the one that we're using is the wide area network, right? The World Wide Web, okay? So we need to have that set in place, okay? Once we have that set in place, right? The one thing you guys learned with going over the theory of IPSec is that we need to make sure we have firewall policies, right? Right? And if we don't have firewall policies, that IPSec tunnel is not going to come up. As you guys can see here, we just have the implicit deny that's under every access control list or ACL on any layer 3 device, okay? Well, we're not going to configure the firewall policy manually. We're going to let the wizard configure. So I'm going to show you guys again, step by step, how the wizard takes care of some of the work and some of the information you need to have whenever configuring IPSec, okay? So we're going to go in the left navigation bar, go to VPN. We're going to go to IPSec wizard, right? And this will take us straight to the wizard, right? But there's another way you can get to the wizard. You can go to IPSec tunnels and go and click on create new and then click IPSec tunnel, okay? So on this page, we have a few things, right? VPN setup, right? What does that mean? It's gonna give us options to configure the name of the tunnel, okay? And this is gonna give the name to phase 1 and phase 2 interface. Okay, so if we go into CLI, we search whatever name we give it, it's gonna show up as phase 1 interface and phase 2 interface. And this is actually what the virtual interface is going to be called within the GUI. Okay, template type. Okay, this is very important. You guys have to know the difference for the exam. We have three different pre-configured template types with a custom option. Okay, has the fourth type. Okay, site to site, so it's strictly FortiGate to FortiGate, and there is no manipulation, right? There's no manipulation in packets or anything like that, right? So FortiGate to FortiGate, that's site to site. Hub and spoke, right? Let's say we have plenty of sites, folks, that connect to one FortiGate hub, okay? So you can set this up as a hub and spoke to be ready to accept IPSec configurations from multiple FortiGates. But of course, as you guys can see, is that we would need BGP running for it to auto-discover this firewall. So that's one of the prerequisites whenever doing the hub and spoke template setup. Okay, remote access, right? We can go ahead and set up SSL VPN with this, right? But it's, I don't want to, and I made a mistake. I should not call it SSL VPN, right? SSL is not the only technology you can use for remote access. You can use IPSec as a technology to connect to a firewall for remote access. So that is available to you. Okay, two different things, IPSec and SSL. Okay, wanted to bring that clarity to you guys. Okay, and of course you have the option connect from Mac OS, from Windows, or an Android. Okay, and of course custom, you can go ahead and do this manually. Okay, I have personally never done custom. I actually want to do it one day, and I will test it in the lab. But I wanted to show you guys the bare bones, how to configure it if we're just connecting FortiGate to FortiGate. Okay, so we're going to click on site to site, right? We're going to call it to site 4. Okay, so we got to site 4. Let's talk about NAT configuration. What does that mean, right? So the first, we have 3 options. The first option we have is no NAT between sites. Okay, so no NAT between sites, meaning that means we don't have any device that is doing packet rewrite that's switching up the source and the destination, or just the source for the packets egressing our network. Okay, right? So to be a little bit more clear, we have the FortiGate, we may have NAT configured there, but in certain setups, right, your ISP may also have a router that's, it plugs into, because that's our customer provided equipment, our CPE that we get from the ISP. And in environments, right, that I've been in, they can also do NAT as well. We need to know that information before we configure our IPSec time. Okay? Right? So you need to make sure, of course, you being the network security engineer, and of course for the exam, if we have, if we have an ISP router beforehand, is it doing, the question you want to ask, is it doing NAT or is it not doing NAT? If it's not doing NAT, then of course the option you want to select is the NAT configuration is no NAT between sites. Okay, let's go into a scenario if it's this site is behind a NAT. We can go ahead and configure that, right? And we know that part. We know, hey, this side is behind NAT, but we don't know about the other side. We're just going to go ahead and configure this side. You're absolutely able to do that. Or maybe we're not behind a NAT and maybe the other side is. We can go ahead and configure that. Okay. All right. So those are the 3 options of NAT configuration you have for this lab. We're going to go ahead and keep it at no NAT between sites. Okay. So remote device type, right? We have either FortiGate or Cisco. Cisco, widely adopted, widely known. So of course, every vendor similar to FortiGate is going to have mentioning Cisco in there somewhere as far as the configuration has it. Cisco had a big impact in the industry. And of course, the open systems interconnection model, the OSI model, of creating a lot of the protocols that we use today. Okay, so we're going to stick to FortiGate, right? It's for our lab. We're going to click next, right? So authentication. Of course, you guys remember the part where it talked about authentication was phase 1, right? This is not necessarily saying in the creation wizard that, hey, this is phase 1, but it's just so coincidental that a lot of the things that we need to configure for phase 1 is in this section, okay? But let's not focus on that, right? So remote device, we have 2 ways to identify it. We can say we're going to identify the remote device either by IP address, or we can identify by the dynamic DNS, right? And this can be something that's configured in your global DNS server that you may have. So you may have GoDaddy, you may have something that hands out certificate, right? Or Cloudflare, or something like that. And it's registered that your IP, your public IP, the fully qualified domain name for that's registered with them with the global DNS is maybe www.mykevia.com. So I can put mykevia.com, no matter if she changes her IP address, maybe she has multiple IP addresses, or I don't know where the IP address just changed. As long as she makes her changes on her side, right, and of course the global DNS entries within Cloudflare or GoDaddy or something like that, I'll just still have the fully qualified domain name, right? The www.mykevia.com. Okay. This lab, we're just going to do the IP address. Okay. So we're going to go ahead and put the remote IP address. The remote IP for site 4 is 5.4.2.2. Okay. We're going to go ahead and set it to our WAN port, and we're going to give it a pre-shared key. Now, the authentication method, we can go ahead and use either a pre-shared key, or we can do a certificate, right? That's what it means by signature. But again, another thing that has to do, that's similar to DNS, is that you need to have a certificate authority provide you with a certificate. Now, I'm not a subject matter expert on certificate. I just started diving into it, but you need to have the correct requirements before utilizing a certificate to configure IPSec. Okay, so just make sure you look up through the admin guides and make sure you have everything in place. Maybe consult with your server team if you're, if the teams are, siloed out, like maybe you're the network security engineer and they're the server team. Make sure you engage with them, because typically server teams are more familiar with certificates. Okay, this lab we're just going to use the pre-shared key. Okay, so let me give it a simple password. Okay, we're going to click next. Next is the policy and routing, right? So without it being said, we're typically going over our phase 2 selectors, right? Basically going over phase 2, but it doesn't say it, but you can think as such, right? We're gonna go ahead and set here the subnets that can reach each other, right? What's gonna be the source and what's gonna be the destination that it can reach. So the local interface, we're gonna put the LAN, and it's automatically gonna populate what the IP address is configured, or that subnet that's configured for this interface on my Fortigate. Now, like Don, like I was telling my Kiwi yesterday, you have to really understand routing and switching and understand your environment, because maybe you may have a transport network. What do I mean by that? Maybe you have a Fortigate that connects to a switch, and that switch has multiple VLANs. And one of the VLANs is just a VLAN that just passes traffic up to the Fortigate. It's not so much assigned to maybe clients, hosts, and servers, and printers, or anything like that. So if you have VLANs, subnets within VLANs on that switch, you need to mention those within here, not so much your transport network. Okay. All right. So for this lab, we just have one network, have one VLAN. So we're going to stick to that, right? Our next network, right, our remote subnet is going to be 192.168.11.0, as we can see here. This is where we want to reach. So we'll go ahead and configure that, right? Okay, all right. Let's take a pit stop here and let's talk about internet access. Well, IPSec, you have the option to do a few things, right? You can, as far as internet access, you can configure your remote peer, right? Or this device to go ahead and perform internet routing strategies for the setup, right? So you have 3 options. You have none, right, as far as regarding internet access, which means this, right? Site-to-site devices communicate over VPN, but internet access does not require VPN. Basically meaning split tunneling, right? So what I mean by that. So for this subnet, right, 172.16.11.0/24, any host within that subnet, if it needs to reach the remote subnet, it's going to go through the IPSec tunnel. If it doesn't require anything for that subnet that's on the other side of the IPSec tunnel, it's just going to go straight to the internet. That's what it means by this none option, okay? And that's what I mean by split tunneling as well. Now, share local. Let's talk about that. Share local. Allow remote sites to use this FortiGate as its internet gateway. What does that mean? That means the other FortiGate, okay, or the other device, right, our IPSec peer. What we're saying here is that we're allowing that other FortiGate to go ahead and for any internet, if they want to reach the internet, if they want to reach Google, YouTube, or what have you, they have to first pass traffic over the IPsec tunnel, and then we're going to send that traffic out to the internet. Okay? That's what they mean by share local. The opposite of that is use remote. Okay? So if you select the use remote option, what it means is that now I'm going to use the other FortiGate that's on the other side of the tunnel, has my internet gateway. Does that make sense? Okay.
Yes.
Okay.
Yes,
Awesome.
it does.
Awesome.
Now,
okay.
Now I
Go
do
ahead.
have a question.
Yeah.
So when it's going over like the internet, the traffic is still like encrypted because it's going through the tunnel, right?
100%.
Okay.
Right. And depending on what you configure, right? If you have a policy to where it's like maybe from tunnel interface to the WAN, right? Maybe you're gonna have a policy that does natting as well to go out to the internet, right? It's going to, of course, it's gonna use that outside interface, but when it's trying to come back to that tunnel, it's gonna take off that that natted interface off of the other FortiGate, and then it's going to go over the IPsec tunnel, right? Encrypted.
Okay.
Okay. All right. So let's click on next, right? And it's letting us know the following settings should be reviewed prior to creating the VPN. So we get to look at the stuff. Phase 1 is the name of it, the local address group. And what happens is us putting all that in, what the wizard is doing is creating these address objects for us. So it's creating address groups, right? It creates the address object and then it puts them in address objects groups, okay? So we have the phase 1 interface, we have the phase 2 interface. It also created a static route. It also created a black hole route, right? And of course, it also created local to remote and reverse policies, firewall policies. So it took care of all that. So this is why personally I love the wizard, because it takes care of all that versus you trying to do it manually via the CLI and then coming in and creating a firewall policy. You can do that, but this is, you have options to do this as well. Okay, we're going to click create. All right, and that's done, right? All right, now for this lab, right, for the VM, typically this would work in a regular environment. We need to go ahead and change a few things for it to work. My prior experience with a FortiGate VM with an EVE-NG is that some of the encryption and hashing methodologies is not available to us being the engineers or the lab users due to licenses, right? So what I mean by that is we're going to take away additional encryption methods. So SHA-1, of course, SHA-1 is better than MD5. So we need to use the lowest, which of course is MD5. And we're going to use the lowest hashing algorithm, or the Diffie-Hellman group, which is going to be 1. And this is just for this lab. Of course, the higher the better, right? But just for this lab, just for the proof of concept, we're going to go ahead and give it a low hashing algorithm of group 1 for Diffie-Hellman, okay? We're going to click okay, and then we're going to go to the phase 2 selectors. Quick Easter egg, PFS, perfect forward secrecy, great technology. It sometimes doesn't work with ISPs, so you have to be very careful. So I honestly would say work with your ISP, make sure, hey, do you guys pass traffic that uses PFS? If it does, excellent. If it does not, then disable it. Okay. All right, we're gonna disable it for now. Do the same thing, MD5. Okay. And what I like to do whenever I'm configuring IPsec is that auto negotiate. And what that means is if the tunnel goes down, maybe it's a bad link, it's a layer 1 issue, the link comes back up, it's automatically, this FortiGate is automatically sending out hellos or negotiation packets to try to come back up. So whenever the link is available, oh, it automatically comes back up. Okay, so we're going to configure that. We see, of course, the lifetime, the seconds, right? And what does this mean? This means every 43,200 seconds, it's going to renegotiate a tunnel, right? And that's for security reasons, right? We don't want the same hash, the same encryption for the same tunnel. It's going to do it every however many seconds you configure. It's going to redo the phase 2 and phase 1. Okay. And if you guys didn't see the phase 1, of course, the key lifetime as well. So it's going to redo that key, okay, between each other. All right. We're going to go ahead and click OK. Now let's go ahead and do the other Fortigate. Okay. So we're going to do the same thing, and we go a little bit quicker this time. All right. And of course, before you guys jumped in, I already have all this pre-configured. We're going to go ahead and go to VPN. We're going to go to the wizard. We know what we're going to call it. To site 3. We know our setup. It to be 6.4.2.2. Right? We do this out here in the interface. We're going to give it a password. Okay. It's possible you can fat finger it. So if the tunnel doesn't come up, take your troubleshooting steps and just make sure you slow it down. We're going to identify our local and remote subnets. Okay. I'm going to access none. I'm going to say create. Awesome. Awesome. All right. And just for this lab, I repeat, just for this lab, we're going to change a few things. Convert to custom tunnel. All right. We're going to remove this. We're going to remove that. All right. We're going to go to phase 2 selectors. All right. We are going to remove PFS. Put on auto negotiate. Take off SHA-1. Right. It's MD5. We're going to click the check. We're going to click OK. All right. Now that we got that up, let's see if the tunnel springs up. Nothing yet. So let's take a look and see. All right. So this is good. So we see phase 1, it's passing it. It may be failing phase 2. So we may be missing something. So let's go ahead and take a look at some logs. All right. Let's go to events, so the VPN. This is going to show us both SSL, of course, IPSec, anything that's related to VPN. So we see phase 1 is working, right? Typically, this means we may just have so the negotiation for phase 1 work. So this telling me this may be a phase 2 issue. So let's go ahead and take a look. Let's make sure we have our firewall policies in place. Yes, so we have our firewall policies in place. Let's go ahead and check. All right. Place. We have still failures. Let's go ahead. Let's go ahead and let's take a look and make sure the address objects match on both sides. So, okay, local is this network. Remote is that network. Okay, let's check the other side. All right. Local is this one. Remote is that. Okay. Now let's go ahead and just double check our tunnels, just to make sure we didn't miss setting or what have you. Let's go ahead and go through. Right. Everything looks fine. That's good. Let's check this. One, good to go. Check this. PFS is off. Looks like everything is clean. All right, excellent. Right. So we need to dig a little bit deeper, of course, to see why this is not working. Let's go ahead and do a couple of packet captures and see what's going on. Okay. We can also look in the CLI if there's an issue, but typically we'll see what's happening via packet capture to tell us why the negotiation is not working. Let's go ahead and do that. With that, I will try to do a force. I'll do a force negotiations. Let's see what happens there. Okay, I am doing two. So that. Capture right there as well, just to be safe. Let's see what's happening. There. Let's negotiate that. Okay. Let's see what's going on. Give me 1 second, guys. Two. And I'm looking at this on my other screen, guys. Go ahead. Okay. Good. Three. Excellent. Good. Let's check site 4. Just rechecking layer 3. See what's going on. Two. Let's two. Okay. Let's do change. Two. Let's check maybe. Well, one, two.
Got a question, David.
Yes, sir.
So like in this case, in this instance, would like a debug tell us why phase 2 is not coming up too?
It's possible. It's possible. Yeah, it's possible. We can do a debug and it'll tell us the errors. I am going to manually
Do the route. Okay.
Yeah, I'm just gonna manually do the route. We shouldn't because we already have a default route, but a quad 0, but we're gonna go ahead and just do that anyway. Oh, yeah. Sometimes the lab is wonky. Find that four, that two, that one. Okay, gotcha.
Why you? I have a question.
Yes, sir. I mean, man, ooh, tripping. Go ahead.
Why didn't you set the interfaces the oh never mind, I think you just did. As the tunnel, like where you're trying to get to. Like
Oh,
basically
what I'm trying to program right now?
yeah, like you're setting the destination right, but aren't like routes for IPsec tunnels like you leave the gateway as the quad zeros and then you set the interfaces the tunnel?
That's a potential config. But again,
Oh,
BGP would be needed because that's auto discovery would be needed, or you would need some type of auto something that would auto magically discover, hey, IPsec is trying to happen here to there. Right? Okay. That makes sense?
yes, it did.
Okay. Um, let's see if this is. All right, now let's test to see if we can ping that network. Ping. For that source. That. Two. Ping. Let's try to ping on gateway. Let's try to ping. Boom. 1.2.1. So we can reach that. Let's see if we can ping. Okay, so that's a good sign. Let's check layer 3 here. Okay, it looks like that site, the IPsec might be up. Again, a little wonky with the lab, so had to add that route in. But yes.
Back to the routes. Actually, I just want to see that route that the tunnel come on.
Yeah, I got you. Give me 1 second.
Can you hover over to site 3_ remote, like the destination?
Got you.
Yes. Oh well, it's not gonna tell me the IP. Okay.
It's the remote subnet for the other firewall, right?
Oh, so 172. Okay.
Yeah.
So it's the LAN of the remote site and then the gateway of that firewall, of this firewall.
Which gateway is that? The 64.2.2, David?
6.4. So that is the IP, the public IP address for the other Fortigate. So site 3.
Okay.
Yeah.
So the other firewall's LAN and firewall IP with the interface of the IPsec on it. Okay, I got it.
Make sense?
Yep.
Okay. Cool. All right. So, of course, you guys saw our tunnel is now. Wait a minute. I think I might have caught the error where we. That's what the error was. We didn't actually need this route. We didn't have a quad 0 route here. That's what the issue was. I got to clear that to .1. And I guarantee you, if I disable this and I disable this, leave, the tunnel should still stay up. Let's go ahead and renegotiate for good measure. Let's bring it down. Okay, let's bring it back up. Let's reload, see what happens. Okay, phase 1 is down, phase 2 is waiting. Okay, let's take a look. Events. Okay, phase 2 status change. Excellent. Okay, so phase 2 is down. Let's see. Negotiating now, and maybe it should be up now. Let's go ahead and take a look. Yeah, it still may be a. Let's see what's going on. Can we get away with just a quad 0?
Wait, I'm confused. How is one side of the tunnel up and not the other one?
Oh, welcome to Fortigates. They run off Linux, and sometimes it holds the session. So I'm going to manually bring down the tunnel. It's probably still sticking to the session. Mind you, this is a VM as well. So.
Oh, like the previous session before that.
So I'm going to bring it manually down. I'm going to bring it up. See what happens. Because it may just be software and cosmetic, but the tunnel might actually be up. Okay, yeah. So it may just be something software because we have everything in place. So I'm just going to turn on the route just for a good measure. Let's go ahead and enable that just for this lab because I really want you guys just to learn the importance of this. And let's just cut this back on. Typically, you don't have to, but for this lab, we just we just had to add that in. Okay, that looks better.
Okay, so ideally, I guess how with the technology of how FortiGate IPsec tunnels are supposed to work, we're not supposed to see that route.
So, yeah, we shouldn't need that route. From a layer 3 standpoint, we shouldn't need that route in place. But again, we're playing with software here. So it may be a lack of resources on my side with the VM. So that might be it, but we're all good.
Okay.
Let's refresh the page because it may be cosmetic just on the page. Might be sticking to the session. There we go. Okay. All right. So both sides of the tunnel is up, right? There were key things we went over. We went over the phase 2 selectors, which of course were the subnets, right? But it was also the other things too that encompassed the phase 2 selectors. So let's go ahead and take a look at that, right? So if we go into the tunnel that we created, we can take a look at everything that that's included. Of course, some things we talked about in theory, some things we didn't. Let's go ahead and cover it, right? So the network, right? What do we put in here? What do we have available to us, right? So when said we're going to use IP address has a purpose of authentication, right? To connect to the other 48, right? So we configure that. We can see that. We see, hey, the remote gateway, right? My peer's address is 5.4.2.2. That is where you would put the other FortiGates or your other layer 3 device that's acting as the other side of an IPsec tunnel. Here's where you would put it, right? That interface you would configure here. Has to say, hey, you dedicate this virtual interface, dedicate it to WAN port 2, right? And where does this reflect that, right? If we go to network and we go to interfaces, we'll go ahead and see, if we go under our WAN port, you see a little plus, right? And our virtual IPsec interface is associated with our ISP interface. So it hangs off of it, okay? So that's what that means. Okay? So if we go back.
Really good. Wow, I did not know that. Oh my God. Oh my God.
So within the network stuff, we have some more stuff. We have a couple things we can configure. We can configure mode config. We can configure DPD, dead peer detection, right? We're gonna go ahead, right? By default, the FortiGate has that enabled, aka on demand or on idle. We're gonna leave that set to on demand because if we can't reach out, like you guys just saw, if our FortiGate cannot reach the peer, right? In this sense, the other FortiGate, it is gonna go ahead and shut the tunnel down. Because what we don't do is we don't want a man in the middle attack to happen, meaning somebody to act as a threat actor and spoof themselves to be our peer. And now our private network and their private network can connect. And now we opened up ourselves to a attack, right? Right? Or a data breach or what have you, right? Anything security related, right? So that's the network portion, right? Authentication, right? Here's where we set, you can go ahead and change this after you configure, after you use the wizard, right? You can use a pre-shared key and you can use a certificate, right? We can go ahead and change that. The real key here in the NSE4 doesn't really touch on IPE version 1 and IPE version 2, right? I personally went ahead and did deep diving for IPE version 1, IPE version 2 because it was here. I implore you guys to do that. It's been a while since I took a look at it, so I can't cover it. If you guys would like me to, I can. I'll just need some time. But IPE version 1 and IPE version 2 has distinctive differences, okay? Along with the different modes that you use. There's a pros and cons for main mode, and there's pros and cons for aggressive mode whenever you're trying to utilize IPSec, okay? All right, and remember, IPE is for phase 1. IPSec is for phase 2, okay? You guys remember that from our theory talks. You can watch the last video, okay? All right. Phase 1 proposal. Okay, here's the nitty and gritty, right? If we're talking about the CIA triad in security, right? Phase 1 is covering, right? It's covering the confidentiality part, the C, and the integrity part, the I. How so, right? Confidentiality, right? If we're holding true to confidentiality, what IPSec is promising me with configuring an encryption protocol is saying the data that's traversing this pipe, it will be encrypted with a specific encryption strategy, right? And an authentication method, okay? Combined together is going to provide confidentiality, right? That's your encryption, right? That's what's going to be providing confidentiality in this sense, right? What about integrity, right? Here's where the Diffie-Hellman group comes in, right? Fortigate likes to use Diffie-Hellman, right? Industry standard, okay? And there's different Diffie-Hellman groups that is going to hash your creation, right, of your IKE tunnel, right? Because of course we need to make sure we have a secure tunnel before we start passing things, right? Because that's what phase 1 is doing. It's saying, hey, all clear, we're good to go, all good, we agree on both sides. Excellent, right? Because the encryption in the Diffie-Hellman group, your encryption and your hashing needs to match both sides, right? There's actually an acronym. I'm going to find that for you guys, so I'll send it in the group. So there's a specific acronym for protocols within IPSec, right? But again, we got our encryption, we got our hashing, which of course we're using the Diffie-Hellman group. Higher is better. Of course, for the VM, we're using the lowest one. That's the only one that would work. So we're using group number 1. Typically, folks go ahead and configure higher, right? So you have those options to you. Key lifetime, very important thing. What does that mean? I think I spoke on it a little bit before. This is where how much each time your key how much your key will be negotiated for that phase of the tunnel. So you can have, maybe you have phase 1, renegotiate that key every 800 seconds, 600 and 400 seconds, however you want to do, right? Just to keep keep threat actors not trying to guess. Because what's happening is you have a vector here, right? This lifetime is the vector that the threat actors have to try to crack your IPsec traffic. Smaller is better.
I got a question now.
Yes, sir.
So the key lifetime, is it like going through all the phase one, everything that it did for phase one for it to come up? Or is it
Absolutely.
like, okay.
And it's in milliseconds, right? It's in milliseconds it's doing this. So traffic, even if traffic becomes interrupted, it has something to do with the ISP. I mean, it's milliseconds where it rekeys and it's still passing traffic.
Okay.
Okay. All right. Let's go ahead and go down to X off. X off, we can go ahead and configure that. What that is, it's telling us, hey, is there a username and password? Configure what's creating this tunnel. We can go ahead and do that. Right. And on the other side, we would go ahead and say, hey, this is a Forti client trying to connect to this, right? What's the username and password? This is when X off would be used. Make sense? This would be that local username and password that we would configure for somebody to connect to Forti client. We'll connect to the IPsec VPN tunnel interface.
So the username, so who enters the client on the other side of the tunnel enters username and password?
It'll be the end user. Because again, SSL is not the only technology that can be used for remote access. We talked about that, right?
Oh, right, I see what you're saying.
Okay. Right? So what we're doing here for XOff is we're providing a username and password that can connect to this IPsec interface.
And is it the same username and password for all?
everyone?
Yeah. Now you're getting it.
Oh, it is? Okay.
Yeah.
Okay.
Yeah. Yeah. Okay.
But wouldn't that be unsafe? Because wouldn't that like
Hey, now you're getting it. Now you're getting it. And it's not so much it's unsafe, it's more so who's it going to cater to? Because it may work for somebody that maybe has a that's just using their FortiGate at the house, and they know that they are the only person that's going to connect to the IPsec tunnel interface. So they just have that configured. But an organization, enterprise level, it doesn't scale well. I'll say that.
so that would be disabled. I think I've seen that.
Yep.
Yeah, I have.
Yep.
Okay.
So we're gonna
Okay,
keep
so
that
best
disabled.
practice to keep that disabled.
Yes.
Okay.
Yeah. All right. So next, we're going to go ahead and move to phase two, right? So phase two, right? Phase two, the first part we're going to see is going to give us the description, right? It's going to say the name here. Here's the name of phase two. You see that right here. It's going to give us description. Hey, this was made by the wizard. Here's the VPN that it's related to, right? To Siteful, right? Then we're going to see something that says local address, remote address. These are your address objects that were created by the wizard. It automatically puts it within the phase two interface that's going to be used. Now, you can have multiple, right? Multiple phase two selectors. Me personally, it'll get confusing doing that. I like to go ahead and say, hey, if you know what's going through what, let's go ahead and just pass put them all in the create address objects and put them all just in the same group and reference it here, right? You do have the option to reference not just address objects, aka named addresses. You can actually specify a subnet, IP range, IP address, IPv6, IPv6 range, what have you, right? For your local and remote address. So you can do that. Okay. Phase two proposal, you can go ahead and this is same thing we saw in phase one, right? Encryption, right? How are we encrypting that traffic at phase two as well? Because this is where data can start to pass, is after phase two is completed. Give me 1 second, guys. One second, guys. I got somebody at the door. All right, my bad, y'all. So, all right, so phase two, it has encryption and hashing as well, right? It has all of that. So you would have to configure that as well. Again, the highest encryption, harder for threat actors to go ahead and crack and manipulate. Okay. So make sure you configure that and make sure that's configured. We spoke about PFS. PFS is our hashing algorithm at phase two. But like I stated, sometimes it works, sometimes it doesn't. If you guys are deploying this, make sure that I would suggest getting on whenever you deploy this, getting on a bridge call with your ISP provider saying, hey, have you guys had any issues passing traffic that uses PFS? If it doesn't, you can go ahead and implement hashing at phase two. If it doesn't, you only just have encryption at phase two if this is disabled. Make sense?
Yep.
Okay.
Yes.
Excellent. Local port, remote port, self-explanatory. We can go ahead and make sure that's set to all. Protocol is going to use the default protocols for IPSec. Okay? And anything related to it. Okay? So we can leave that as checked, right? Auto negotiate. You can leave this on or you can leave it off. Me personally, right? We talked about that key, right? That key lifetime where it renegotiates. And Don, you had a great question. Like, hey, so it's going to automatically negotiate? Yes. But what happens if it's time to renegotiate and maybe out of nowhere we have a layer one issue, maybe on our side or the other side? Then out of nowhere, it goes ahead and tries to connect and it can't reach it, right? Then the link comes back up, but we have on negotiate disabled. It's never going to try to bring back up the tunnel by itself. It's going to stay down until somebody manually comes in and tries to open up, tries to bring up that phase one and phase two interface. So you have to manually do that. So Don, if you're in Puerto Rico and this happens, you would have to go on site and go ahead and make this change.
Oh, wow.
Yes. Yes. So this is a little feature to help us out as engineers so that, of course, hey, something goes wrong, maybe it's an ISP, link blip, it comes back up, it'll go ahead and come back up itself. Okay? And same thing as fake. Go ahead.
I was gonna say I got two questions, but I'm gonna wait. You might cover them.
Go ahead.
Okay, so if you have covered this, like I've had situations that they wanted to add like another subnet under the IPsec tunnel to like they needed to communicate with another subnet under that same tunnel. Do I just add the route for that tunnel and add the local and remote subnet that they want to reach here?
Don, help me out. Say it again.
Like I've had situations like say for it's a site that they have like their phone server or something else that they want to communicate over this IPsec tunnel, another like subnet. And I had to add like multiple subnets under one tunnel for them to reach that destination. And to accomplish that, do you just create a route for the tunnel? And I'm probably making no sense. Never mind.
No, you are. So
okay.
I know what you're alluding to. So there's no right and wrong answer, right? So like I said, right, you can add, right? If this was a paid version, I would have the ability to add, right here, right? So I can add another phase two selector, right? But why would I do that? That would just make things hard.
Okay.
Right? I can do it, but what's going to happen is on the other side, they're going to have different phase two selectors.
Oh, okay. I see.
You know what I mean? So if I have already a address object group,
I see.
Right? From a layer 3 standpoint, I don't need to say, oh, it's the voice VLAN, it's the data VLAN. All this IPsec tunnel is going to say, from a layer 3 standpoint, what subnets need to reach what.
Okay.
Okay? Yeah. So if I have that set, and if I just need to add a little bit, if I need to add more subnets, I'm just going to go ahead and create the address object and just put that under what's local,
Mhm.
and what's remote.
Okay.
Boom,
Gotcha.
done. Now, again, me saying that is not saying there's a right and a wrong way to do it. Because like I told you guys before, every vendor is going to let you do whatever you want. So if you want to do the other way, that's perfectly fine. You just know if you're looking at the tunnels, right? And if we go to, right, if we go to the IPSec, right, maybe phase one will just have one entry. But since we now have different phase two selectors, there's going to be different phase two interfaces.
Okay, I see.
Does that make sense?
Yeah, it does. And
Okay.
I see why we do it now that you kind of explain it, because it was firewalls that we managed, both firewalls, and they had multiple subnets. So that's why I think that's why we did it.
Okay.
My next question would be, like, I've worked on IPsec tunnels, and like all this stuff checks out,
Mhm.
and the tunnel still, like, it would just go down miraculously, like it, like, just out of nowhere. It just, all this stuff is checked out, and I resort to like rebuilding the entire tunnel to get it back up.
Mhm.
Like, do you know what would cause that? What are potential causes for that to just like? Because I thought the tunnel is just everything matching up. Like, if it matches up, the tunnel's gonna go up. So, what
That's a
would
good
cause it
question.
to go
No,
down?
that's a good question. So, first thing you have to take out of your mind is, if the tunnel is down, that means everything doesn't check out or match up. Something's going on, right? And it may not be within the configuration. It may just be at layer 3.
Okay.
Okay.
Mhm.
Right. So it may be something to where the tunnel came up, then it went immediately down. Something at layer 3 is happening. Maybe somewhere, some application on the Fortigate, something is happening, or the Fortigate's at its limit from a hardware standpoint, right? And maybe within the kernel, right? Because it runs on Linux, more specifically CentOS, maybe an application that banks on that IPsec relies on, maybe it's crashing. So maybe a hardware issue that you don't even know about, right? Within the hardware or software. So that's possible. Maybe the ISP maybe they have a firewall, maybe it's blocking something. It's possible, right? But it's not everything. If something's not working, that means everything doesn't check out.
Okay.
Okay.
I didn't even think
But
like that. Fair enough. Yeah.
yeah.
Makes sense.
So if things don't work, then that means you need to investigate further, right? And dot all your I's and cross all your T's. But you being the engineer, and me and my key were going over this yesterday, is know when your limit is. If you have nowhere else to go as an engineer, just stop. Ask for help. Right? And just share your notes. Like, hey, look, I checked this, I checked that, maybe I'm missing something. Right? And then you move forward. Make sense?
Yep. This was great. Yep. Yep.
Okay. Cool.
Yes.
Cool. All right. So, of course, we went over that. And I think the last piece I had to go over is, of course, same thing, right? Key lifetime and seconds correlate with each other. The key, of course, this is the key that's used for phase 2 for the respective phase, right? So phase 2 has one. Of course, that lifetime, we can set it to seconds. We can set it to kilobytes, right? We can set it to both. So it's possible, right? So you can set it up to however much you need. Of course, Fortinet went ahead and added this feature. Of course, end users asked for it, right? And it's NSE4s all around the world went ahead and asked for it, say, hey, we need this for this, we have a need for this. So the software devs added it in, right? And of course, this FortiGate is on code train 7.0.0. I believe the exam is on 7.2.0 or 7.4.0. I believe it's maybe just 7.2, but all is the same, right? The code may be different, okay? So that encompasses, everything about that we covered, right? For the NSE4, about configuring IPsec tunnel, troubleshooting it, right? And the last thing we didn't do, and I'm glad I just remembered, is looking at the logs and how the log is supposed to look. So so our IPsec tunnel is up, right? How do we take a look at, make sure phase 1 and phase 2 is working or it's not working? So we go to log and report, we go to the events section, and we click on VPN events, right? Like I shared with you guys, it's going to show both phase 1 and phase 2. As you guys see here, phase 1, right? Went ahead and let us know all the details, right? Phase 2, it's working. It's showing us the hashing algorithm. It's showing us the encryption algorithm. Boom, showing us all the information, right? And it's telling us the status. It's a success. It's working. Everything's good, right? We could also see, and keep in mind with this, right? We should see failures, right? We should see failures, but cosmetically, right? Meaning that you may not see it. It may be that on this code, you can't see where the status is failure, right? Okay.
Yep.
Higher codes, it'll show you, hey, phase 1 work, phase 2 keep failing. Okay.
I have
All
another
right.
question. I'm
Oh
sorry.
yeah, go ahead.
So like the traffic over that's
Yes,
going over the tunnel,
yes.
how would you look at that, and like how would you handle a situation that they're like, I have slow traffic over the tunnel? Like, is that just like an ISP? Is it safe to just assume that it's an ISP issue, or is it like, because it's, I don't know, like how would you fix that?
No, that's a good question. So you're saying if it's a situation of maybe traffic, end users are reporting traffic is slow, right?
Yeah.
And you're trying to say you're and correct me if I'm wrong, you're trying to say that it potentially could be the tunnel?
Yeah, correct.
Okay.
Potentially it's a tunnel, and I'm like, how could that? Because the tunnel is just passing the traffic, so I mean,
Yeah,
it's not doing much.
you just answered your own question, right?
Okay.
So what's going to happen, right, is the maximum transmission unit, right? It's 1,500 megabytes, right? Throughout each interface, correct? By default,
Uh-huh. Yep.
right? Out of each interface. So with that being said, right? So if we're participating in IPsec, right? That IPsec tunnel is adding an extra layer within that packet that's supposed to be in size 1,500. So regularly, right, data packets that pass and that have so much size to pass data, now it's shrunk. So what does this mean? We need to go ahead and cut up the packets, right, that we're passing up. So the packets may be broken up even more, but that doesn't mean that it's going to be the cause of traffic being slower. Yeah, maybe they're doing a download. Maybe they're downloading something, right? From another remote site, right? Maybe from a file server, and it's, versus not going over IPsec tunnel, maybe it's a little bit slower because, of course, that traffic has been broken up. But that's the only way we can say maybe it's slow, but it still depends on the pipe that you have with your ISP,
Okay.
right? It's always going to, right? And again, milliseconds. So if we removed IPsec and maybe we said, hey, cloud gateway, if we need to reach this other site, go this way, right? Instead of it going through IPsec, we can say that, but it's still, speed is probably going to increase by 2 milliseconds. I mean, it's still going to be the same. All it's doing is securing your traffic. IPsec. That's it. Nothing to do with slowing down your internet traffic or what have you.
Okay.
Make sense?
Yep.
Okay. So all it'll take is just troubleshooting a bit more and doing stress tests, of course, before you implement it. And you test it out and see, hey, what's our SLA, right? What do we have, what do we have agreed with our ISP? Is it giving us a 50 meg pipe, a 300 by 300 meg pipe, a gig pipe, something, a symmetrical pipe or what have you, whatever they're giving us, right? Is this matching up, right? So that's a couple of things that you can use to go ahead and troubleshoot and see what's going on. That makes sense?
Yep.
Okay. Right. Any other questions?
I'm good.
Okay.
No,
Last,
not really.
last but not least, we do need to do one last test. Okay. Because we didn't actually see how that traffic looks passing over, right, the internet. Okay. Or pinging from one site to another, if that makes sense. Okay. So let's go ahead and test that. You go ahead and bring up the packet capture. Okay. Let's see. Is packet capture working? Maybe not. Let's go ahead and try it again. Okay. Let's see if I pick something up. There we go. All right. So I'm going to pull PC8. PC8 should be right here, right behind site. Let's go ahead and see if we can go ahead and ping our remote now. All right. And let's, all right. So this is our IP 192.168.11.50. And I want to go ahead and try to reach our remote network. All right. 172.16.11.50. Okay. Let's go and give it a shot. Right. Okay. So the ping stopped. Let's go ahead and take a look at this. Right. Let's go ahead and do SP. All right. So what do we see here? Right. What do we see? Right. We don't see the source and destination to be the we don't see it to be the LAN addresses. We see it as, of course, the outside addresses, but more specifically, we see ESP being used, encapsulating security payload. So it's encrypting that payload, that data that's passing through the IPsec tunnel. Even the source and destinations are protected, right? They're rewritten, right, to go on that public untrusted network. So this is how it's supposed to look if traffic is traversing traversing that public internet. Okay, you're not going to see if we're looking at a packet capture, we're not going to see data. We're not going to see within the info part data. We're just going to see ESP. Here's the sequence, right? If it's following a sequence, here's how it looks. That's it, right? So we see through a packet capture, this is how it's protecting our traffic. If we have a bad actor that's trying to listen in, right, on traffic that's traversing, they can't see anything. They can't even crack down this packet. It's encrypted and it's hashed as well. That's what we configure. Does that make sense?
Yes.
Yeah.
But if we take a look at it, right, we go ahead and say, hey, let's see how that traffic looks if it's passing through the local area network. All right. Let's go ahead and okay it. Let's do another ping. All right. And maybe it's stalled out. Let's go ahead. Let's do continuous pings. All right. Let's do the capture here. Let's do port 4. What do you guys see for the source and destination?
You see the actual source and destination.
Exactly. Now you see how IPsec works?
Yes.
Makes sense?
So it's encrypted when it goes over the internet, but like okay.
Yeah. Makes sense.
Yep.
Okay. All right, guys. I'll go ahead and let you go. We will have a session tomorrow. So I'll see you guys at 10. You guys have a great night.
Oh, we are or we're not?
No, we are.
Oh, we are tomorrow still?
Yes, yes,
Okay.
yes. We're all good. Yeah, my conference is until I don't have to be there till 4:30. So you're all good.
Okay, awesome. Yay.
All right,
Okay.
guys.
Awesome. Okay.
Have a
Later.
good night. Bye, guys.
Bye.